Good day and welcome to this episode. Have you ever heard of a topic ever tricky in elementary maths? This is differentiation, and it's actually a simple topic, but people just they have this fear for it. In this episode, I'm going to be breaking down some basics of differentiation. This is the first part, and we're going to be dealing with different cases under it. So, without wasting much of our time, I'm going to get into this. Now, we have different basic functions of differentiation. When you are differentiating some trigonometric functions, they have their constant results. So I'm going to be checking them now. For sine x, e is sine x. If you differentiate sine x, you will have cos x. So that is the constant differentiation for sine. Then for cos, if you are differentiating cos x, we have minus sine x. Now the logic is when you differentiate sine x, you will get minus cos x. So you are integrating it back, you get this back. The same thing here. So since differentiation is the opposite of integration, whatever you integrate to be the answer, if you integrate it back, it must give you that differentiation. So that's just the logic. Now for tan x, if you differentiate tan x, it's going to give you sec square x. Are we following now? So it's going to give you sec square x. So these are the three main functions. Then this one are the inverses of this. They are the inverses of this. So the inverse of this x means 1 over cos. The third letter is c. So that's 1 over cos. So this cot means 1 over tan. The third letter is t. So it's 1 over tan. It's 1 over this. So this one means 1 over sine because the third letter is s. So that's the logic that we use for all of them. So now if you are integrating sec x, we'll be having sec square x, then tan x. We'll be having sec square x tan x. So that's for sec. If you differentiate it, you will have sec square x dot tan x. So for cot x, if you differentiate cot x, it will give you minus cosec x square. You get minus cosec x square, or you say minus cosec square x. Let me put it that way, minus cosec square x. So that is for cot. Now for cosec, if you are differentiating cosec, you will have cosec x and cot x. You just have to know this, cosec x and cot x. So these are the basic differential functions I can say we need for now, just to know the basics. So because due to your objective that you are doing in this elementary first year, you don't need much of theory, but you need to know them basically. You need more of shortcuts for now. And I'll be doing that on the shorts, the YouTube shorts. But for now, let's just know the basic and the preparation for the differentiation. So I'll be diving to that when it is time. So now to write the meaning of all this cosec, and I already told us that this s, that means 1 over sine. So this means 1 over sine x. Here this is sec, and this is third letter, this cos. So it will be 1 over cos, 1 over cos x. Then cot, that is 1 over tan. So it's going to be 1 over tan x. This you have to master all these functions. They are very, very, very important. Now without wasting much of our time, we are moving to cases in differentiation. We have different kind of cases. As we can see, there is power case, there is sum and difference case, there is multiplication and fractional case, and there are some cases that we can also have the combination of case 2 and case 3. So let us pay full attention. Now the first question, the power case. This is when you are having raised to power. Mostly it's like a polynomial function. So you can have a polynomial function like this now, and they ask you to differentiate it. So when you are differentiating a polynomial function like this, you take the power, multiply it by the coefficient of the number, then that power will be minus 1. Do you get? So this is the logic. You say dy dx will be equals to, this 4 is the power, right? Multiply it by the coefficient, that is 5. So you will have 4 multiplied by 5. Then this x, that's 4 that is the power, you minus it by 1. So you'll be having 4 minus 1. I'm doing this because I'm just explaining. I don't need to write this on the norms. So now 4 times 5 will be what? 4 times 5, that's 20 x raised to power what? 3. So that is the differentiation of this y. The y dx is what? 20x raised to power 3. Now let's look at this. This one might look somehow confusing. We have y is equals to w. You may ask me how do you want to do this? But this has a power of 1. This w has a power of 1, and it also have a coefficient of 1, because 1 w is still w, then w raised to power 1 is still 1. Yeah, it's still w rather. So then if you want to do this, just say 1 multiplied by 1, that's 1, then w raised to power 1 minus 1. Do we get that? So that's the logic. When we calculate that, we see that this w will be raised to power 0 here. So w raised to power 0, and anything raised to power 0 is what? 1. That shows you that if you are differentiating a variable, the answer will always be what? 1. If you are differentiating a variable, maybe it's y, maybe it's x, it's only if that variable has a coefficient, that's when it will not lead to 1. So that's all for power case, and you can always drop your questions in the comment section. So now the sum and difference case. Now we are having y. Sum and difference case, it has to do with the function they are giving you with respect to the function in the variables that is in the other side. So like now we are having y is equals to 5x raised to power 4 then plus u raised to power 7. You can see that we have y with respect to x. In this case we have only y with respect to x only. That was the only function it was with respect to. But here now we are having y with respect to x, and we are also having y with respect to u. So now if you are going to answer this now, they can either ask you to find dy dx or ask you to find dy du. So it's not left to you. So when you are doing sum or difference, you pick the one you are concerned with. So let's go. Dy dx now. I will face the one that has x only, which is this. This has x only. So what am I doing here? 4 multiplied by 5, then x raised to power 4 minus 1, right? So 4 times 5 is what? 20. Then x raised to power 4 minus 1 is what? 3. So that's for that. I don't need to touch this because they did not ask me to touch you. So now if they now ask me that dy du is what, that means y with respect to u. Now I don't need this place again. I only focus on what they're asking me. So if I want to do this now, this one will be what? 7 multiplied by 1 here, that will be 7, then u raised to power 7 minus 1. So that was this one give us 7, then u raised to power 7 minus 1, that will be 6. So the differentiation of this y with respect to x will give us this, and the differentiation of this and y with respect to u will give us this. So then we move to the next question. Let's do one more on this case, too. So now we have this one again. Now you can see that x is with respect to v, and x is with respect to w again. So that means we can find the x dv. We can also find the x dw, right? The x dw. So we can find the x dv and the x dw. Now the x dv will be what? Yeah, I'm dealing with this now. So that would be 5 multiplied by 3, then v raised to power 5 minus 1. Are we getting the flow? So that would be what? 15 v, then 5 minus 1 will be what? 4. That's for that. Then for here, the x dw. Now note this minus. There's a minus there. So 10 multiplied by minus 2, that would be minus 20. Then w raised to power 10 minus 1 is what? 9. So you have to take note of that sign. So that's why it's called sum and difference case. Let's move to the next one. We are having multiplication and fractional case on that side. Multiplication and fractional case. So now in this multiplication and fractional case, it is different to sum and difference case in the sense that, you know, in sum and difference you only face what you are with respect to, and you leave the other side without writing it. But in multiplication case, when you are differentiating with the one you are concerned with, you will also write the second one, but you will not differentiate it. Do you get my point? Now you are having here y with respect to v and y with respect to w. So now I can say dy dv, and I can also get dy dw too. Now but this is product. They are associated with what? Product. Here they are associated with plus. Here they were associated with minus. So but here it is product. You can see they are multiplied by each other. So now if I'm going to look for dy dv, it's going to be this 3. Note that this 3 is for this and this. So this 3 is for this v raised to power 5, is also for this w raised to power 10. So now I'm concerned with v for now. I will say 5 multiplied by 3, which is what? 15. Then v raised to power 5 minus 1, that is 4, right? Then I will now write this one that I did not differentiate, that I'm not concerned with. I will write it beside it, w raised to power 10. So like that, I've performed this case. Remember, you are going to face the one you are concerned with, dy dv, right? So I differentiated this and I wrote this like that. So that's for the first one. Now dy dw will be what? Since I said this 3 is for both of them, so this 10 will multiply this 3, it will give us 30. Then 30w raised to power what? 9. 10 minus 1. So but you need to write this v raised to power 5 also in between. So what I'm doing now is going to be 30 v5, then w raised to power what? 9. That's just it. It's as simple as that. So for this, we have fractional case here. It's also the same thing. So it's almost the same thing with this. So you just have to multiply the power by the coefficient. This is the coefficient here now, 5 over 18. There's nothing special there. So you just have to save 3 into brackets 5 over 18, then x raised to power 3 minus 1, the power of minus 1. Then that will be 3 multiplied by 5, that's 15 over 18. Then x raised to power 3 minus 1 is 2, right? So yes, and you can break it down to the lowest terms. 5 and 3 can go here, 3 can go here too. So I'll say 3 in 15, that's 5. Then 3 in 18, that's 6. So that's 5 over 6 x squared. So let's say they ask you to do the second derivative. You know, second derivative is the square y dx squared, right? Let me just chip in that too. The square y dx squared of this will be what? You are still going to take, you are repeating the process, so you are taking 2 multiplied by this. So if you multiply 2 by 5 over 6, that will be what? 2 multiplied by 5, that's 10. So 10 over 6 x. 2 minus 1 will give us 1. So 1 minus 2 minus 1 is still 1. So x raised to power 1 is still x. So now you can break into lowest terms. 2 can go here, 2 can go here. 2 here will be what? 5. Then 2 here will be what? 3. So the second derivative will be what? 5 over 3x. So now we'll be moving to the next part. We'll do one more on this case and we combine. Now, continuing on the multiplication case, this is another question that we can solve here. I think this is supposed to be y. So y with respect to x and y with respect to u. So we have dy dx. We also have dy du. Now to solve this now, I already told us before that we will face what we are concerned with, differentiate that, and we write the second one like that. So now it's going to be dy dx. We are facing this here. So that will be 4 multiplied by 5, which is what? 20, x raised to power 4 minus 1, which is what? 3. Then we write this one like that. So now for the y du now, I'm facing this. So this 7 will multiply this 5. Remember I said the 5 is for both of them. So this 7 multiply this 5, that's 7 times 5, 35. I'm writing this, remember, like I'm not facing that for now, I'm facing this. So u raised to power 7 minus 1, this is going to be 6. So that is for this. Now here we are, this is the last part, combining case 2 and case 3. We are combining addition, subtraction and multiplication together. So now it's very simple. You have to be calm and you have to be very careful. In this single question, I can differentiate to 4 with respect to 4 entities. I can say y with respect to x, I can say y with respect to u, I can say y with respect to v, and I can say y with respect to w. So you have to be very careful. Let me write everything out. Dy dx, we have dy du, we have dy dv, and we also have dy dw. Now straight to the point. So I'm going to start this now. We have x here, we also have x here, right? So I'm concerned with where I'm having x only. But in case I have multiplication that is tight binding them together, I will consider putting the second one that is beside it, that is associated with it, with multiplication. I will write it like that, just the way I did here. So what I'm just going to do is that I will face that x I'm concerned with, and I will write the second one like that. Then here I don't need to do anything here. I will omit this one because there is no x here. Then x is here again. I will have to multiply, then do the differentiation law here, and whatever is remaining, I'll write it like that. You understand? So Let's move on. So now divide the x now. For here now it will be what? 3 raised to 3 multiplied by 4, that's 12. X raised to power what? 3 minus 1, that's 2. And I write u7. Then here I don't have anything to do here. Then plus x here. X here. So x raised to power 1. X raised to power 1 here. So x raised to power 1, if 1 multiply 1 at the back here, it's still going to be x. Then x raised to power 1 minus 1, that's 0. So, and anything raised to power 0 is what? 1. Do you see now? So, I will write this w5 with it. So, you can see that it is complete like that. I differentiated the x here, I wrote this one like with it. Then I came here to I differentiated that x. Don't do mistake by putting this power for this x. No, it's only when they have coefficient like this, that is for the two of them. Do you understand? So now the y du, now let's go. We are differentiating for the y du. This one is only we have u only in this place. So we are going to be saying 7 multiplied by 4 because the two of them that have it. So 7 multiplied by 4, that will be 28. 28. I'll write this x square, of course, then x cube rather. Then u raised to power 7 minus 1 is what? 6. So divide the v. Let's divide the v will be what? It's only this place I'm having v. So I'm differentiating this, that will be 2v raised to power 1, right? Because 2 is multiplying the 1 here. So it's going to be 2v raised to power 2 minus 1, which is 1. So I can, this one doesn't have any meaning here. So I'll just say 2v. But note that there's minus there. We're going to add minus. So that's going to be minus 2v. You have to be cautious of the sign. So lastly, for dy w, we have w only here. So and w is raised to power 5. But I'm going to differentiate it. That will be 5 multiplied by 1. You know I said there's 1 here. 5 multiplied by 1. That will be 5w raised to power what? 5 minus 1. So that is 4. So 5w raised to power 4. Then I need to write this x2 because it is associated with it with what? Multiplication. You either write it like this or you write it like this. 5xw raised to power 4. So this is the first part of the differentiation. Do well to like, comment and subscribe. Also anticipate for the second part coming very soon. Thank you.